So here this is the rational equations, I think. Is this on part 1? So this is solving rational equations. The idea is you have to get a common denominator before you can do any adding or subtracting or solving. But also we have to get this 3 to be a fraction, so we put it over 1. And even though it wasn't a fraction, we still have to get a common denominator for it. And we're going to figure out our common denominator. Now for this one, it looks like I would want to take x plus 1, just kind of be this my common denominator, but remember, to get a common denominator you have to multiply. So we're going to multiply these two together. So my common denominator is going to be x times x plus 1. That's my common denominator. So now it's just a matter of multiplying each fraction by what I need to get that common denominator. So this first one needs an x plus 1. So I multiply top and bottom. The second one needs just an x. And the 3 here needs the x and the x plus 1. Okay, so then I'm going to go through and simplify the top. So I have to multiply through by 1. So then we get 1x plus 1. I multiply these together, and I have a minus in front, so it's going to be a minus x. Now be careful there, because here is where a lot of people make mistakes, because if you were multiplying by a bubble, you know, if you had the x plus 1, if that was right there, and you had to multiply by 1, you'd have to take that minus sign with it and distribute that through. So just be really careful. I think on the test, on one of your tests, either this year or last year, that was one of the big mistakes. People didn't take that minus and multiply it through. And then we have equals, and then I need to take this 3x and multiply that through. So I get 3x squared plus 3x. And all of that is over x times x plus 1. And really, I'm only worried about the top being equal because the bottom is already x times x plus 1. So this is that place where we get to ignore the bottom. This is the one time you get to ignore the bottom. And then on the top, I'm going to simplify. The x's cancel out, so then I just get a 1 equals 3x squared plus 3x. Subtract 1 from both sides, so then 0 equals 3x squared plus 3x minus 1. Now, what's difficult about this is you cannot just box out set equal to 0 and solve. You're going to have to use the quadratic formula for this. So this is really actually just kind of a weird problem just because you don't come up with a good answer. But, so we use quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times 3 times negative 1, so it'll be plus 12, all over 2 times 3 is 6. So you get negative 3 plus or minus the square root of 21 over 6. 21 can't be square rooted, I can't simplify, so this would be my answer, which is not normal. I'm not going to do that on the test. On the test, you'll be able to take this and box it out. And just remember, whatever answer you get, remember you'll set these equal to 0 and you'll get x equals 2, x equals negative 1. Let's just say that's what you got. You didn't really, but let's just pretend. This negative 1 you'd have to cross off, because if you plug in negative 1 here, it makes the bottom equal to 0, and you can't divide by 0. So you always want to check that kind of thing. All right. Was there? Yes, ask a question.
Can we take a 3 out of them, or is that...
Can you take a 3 out of what?
Like the negative 3 plus or minus 3.
Here?
Yeah.
No, because, so you cannot take a 3 out of here, because this 21 is not really 21, it's the square root of 21. If there was a 3 in front of here, then yes, we would cancel out a 3. But that 21 is locked inside that square root, so you can't do anything. Unless this was in a square root, then you could. But you can't when it's just that. Any other questions? All right, next problem then. We're supposed to graph a circle. So if I'm just first identifying things, the bubbles tell me, these guys tell me my center. And so the center, woo, let's get rid of that, wrong button. Okay, the center is the x value. You're going to take that and you're going to do the opposite. Take that, do the opposite. Okay, remember how it was, the original setup is x minus h squared plus y minus k squared. So the minus is already there. It's what's here is your center value, whether it's x or y. Okay, and then the radius is the square root of 16, so the radius is 4. So if that's all I ask, if I just ask for the center and the radius, that's what you're going to do. But I'm guessing you'll be graphing. So to graph, I find the center, so negative 2 and 5. And I'll give you grid paper for this, not like this. And then the radius is 4, so I'm going to count over 1, 2, 3, 4 in all directions. And wow, are my axes off a bit here, but anyway, this is your circle. Yeah. Let's pretend it went way out there. Okay, you get the idea. It'll be real grid paper, so it'll be properly spaced. But again, you just find your center. And the biggest place people make mistakes is forgetting to do the opposite. Okay, so we need to make sure that these are the opposite of them. And if the problem said x squared plus x minus 5 squared equals 16, if that's what it said, then for the center, the y value is still 5, but notice it's not, there's nothing with the x, so basically you're saying x plus 0 squared, because there's nothing with the x, so then your x value would be 0. Okay. Any other questions about this circle? All right. Symmetry. You have 3 kinds of symmetry. You have x-axis symmetry, y-axis symmetry, and origin symmetry. Now, I always draw myself a little picture to figure out what kind of symmetry is what. And how am I going to figure it out? X-axis symmetry, if I have a point there, it reflects on the x-axis. So you'll notice the x value is the same. It's just that the y value goes from one to the other side. So I'm changing from a positive y to a negative y. Or maybe I was already at a negative y and now I'm changing to a positive y. But either way, what you're going to do to figure out x-axis symmetry is you're going to plug in a negative y for the y right there. So I plug in negative y equals x squared plus 5. And once you've done that, now it's your job to look at it and say, can you simplify it so that it looks exactly like this again? Now, if I look, this side is identical. It's just the y that's negative. And if I was to multiply by -1, that means I'd have to multiply these by -1, which would then mean it wouldn't be the same. So at this point, there is no x-axis symmetry. Okay, then we go to y-axis symmetry. In that picture, if I have this point right here and I reflect on the y-axis, my y value stays the same, but if I had a positive x value, it's now in the negative spot, or vice versa. If I had a negative x value, it's now in the positive spot. And so to figure out if it has y-axis symmetry, I'm going to plug in a negative x. And you'll notice that that x is squared, so I have to use a bubble here to make sure that the negative is being squared also, because I'm replacing the x. And the x is what's being squared. So when I do that, I do the squared math there. Negative squared is positive, so now it's just x squared plus 5. And I managed to get back to the original, so it does have y-axis symmetry. Okay, and then we have origin symmetry, and the picture for that is if I have this point, I'm going to reflect over the origin, which means now when I had a positive x, I have a negative x. When I had a positive y, I have a negative y. And of course, if I'm not starting in this first quadrant like this, what if I started over here, then the point would be over here and my positive and negative would switch, okay? I just want to make sure you guys understand it's not always from this point. It might be from a point over here. But I usually start there just to make it a little bit more simplified. So I had a positive x, but now I have a negative x. Here I had a positive y, but now I have a negative y. So I'm switching both x and y. So I go back to my original, and I plug in a negative x and a negative y. I simplify what I can, right? The negative y, there was nothing to do, but then the negative being squared makes it a positive. And now I'm back to the same situation I was over here, where there's nothing I can do to get back to the original, so it doesn't have origin symmetry. Now, I have seen problems where it has all 3 symmetries. I've seen problems where it has just 1 symmetry. I've seen problems where it has no symmetry. So you're not guaranteed that because you find one of them working, then the other one's not automatically. You have to do all 3 of them to check them all 3. Okay? Any questions for symmetry? The trickiest part I've seen with the problem is one like if the problem was y equals x cubed, and let me check origin. So I plug in a negative y, plug in a negative x. I get negative y equals negative x cubed, because when you cube a negative, you still get a negative, right? And then you have the x still being cubed. So it's like you cubed the negative and you cubed the x. So this is what I get. And then you look at it and you say, well, that's not the original. But I still can go and multiply the whole thing by -1. So that if I do that, a negative 1 times y is a positive y. A negative 1 times a negative x cubed is a positive x cubed, and I managed to get back to the original because I multiplied everything by negative 1. So don't forget that's an option. Multiply everything by negative 1. Okay? Any questions? All right. Okay, page 120, number 16. It says, you drop a coin from the top of the Eiffel Tower in Paris. The building has a height of 984 feet. Okay, so the height is 984 feet. Now I'm not, the height, I don't know what to, okay. Use the position equation to write a mathematical model for the height of the coin. So the position equation is h equals negative 16t squared plus vt plus h sub 0. And if you remember what all these stand for, this is the ending height, this is time in seconds, this is the initial velocity, and this is the starting height. Whenever you see a little 0 on the beginning, it's just the starting, okay, or original. So when we say 984, I kind of got upset by having just an h, because I'm not saying that this is that. I'm just saying the height of the Eiffel Tower is 984, just taking notes, okay? So where should the 984? Should it go in for this height or this height?
The initial height.
The initial height, right? Because we're saying we're dropping a coin from the top of the Eiffel Tower. We're not dropping it from, we're not saying we're on the ground and we threw it to the top of the Eiffel Tower, right? And so we're saying our initial height is this. So I'm going to rewrite it. H equals negative 16t squared plus vt. Oh, wait. What about the v? The initial velocity. If we're dropping a coin from the top of the Eiffel Tower, what's going on with the initial velocity?
Nothing.
Did we throw it? Did we put force behind it? No, it had no force, which means velocity is 0. Which means 0 times t is 0. So this completely cancels out. Yes, and 984 for our starting height, and then Andre said, wouldn't the ending height be 0? So we can put a 0 in there also. Okay, I'm not sure if they totally wanted that actually. I'm gonna put it back as h. Just because as I read the next equation, or next problem, it says find the height of the coin after 4 seconds. So we'd plug in a 4 there, right? Now, part C says, how long will it take before the coin strikes the ground? And that's where we plug in a 0, and we go ahead and solve this. Now, there's all kinds of ways of solving this. We could use a quadratic formula, which, if nothing else, go for that. You know, that's always going to work. This one, because the t is missing, we can just go through all the work of subtracting 984. So you get negative 984 equals negative 16t squared. Divide by negative 16. Okay, so I've got 984 divided by 16. That's gross. Okay, that's because it was wrong. Okay. Let me try that again. You can't see my calculator on the big board? Yeah, you can. Not as I type, I can't see it either. Okay, so 61.5. So we get 61.5 equals t squared. And then, you know, these are the ones where you need to, you know, do the square root because, and get it as a decimal because it doesn't make sense otherwise. So we'll say t equals, and I'll square root that. It's hard to use this in this form. Where's my equals now? So then I get 7.84, and technically I get plus or minus 7.84, but coins don't go back in time. So 7.84, then for how many seconds it'll take, okay? Now, if I still had the t there, so instead, if I still had the t in, what part, this part, I would have used the quadratic formula instead of just solving for t. Instead of solving for t squared, you know, if I had a t right here, I would solve for, use the quadratic formula to solve it. Okay, how do you feel about that one? Do you want me to do another one that does have an initial velocity? Nobody's saying anything.
It's probably easier.
Well, it doesn't matter what looks easier. It matters what matters on the test. I don't know.
We didn't have initial velocity on the test.
I don't know. Is this on the list of things? Or did we just find it on a test and decide to try it out? I don't see it on there. Okay, we'll go on to the next one. We can do it another day if you decide you want to. Okay, so here we have a logarithm very similar to the one on the test, just not the same exact one. Many people struggled with this. You either got it or you didn't, basically. The first thing I'm going to do is I don't like this cubed root business going on right here, so I'm going to rewrite that. So I still have 3/4 log base 5 of 7 to the 1/3. So now I have this exponent that I can work with. Oh, I need to change this. This is ridiculous. I should have put a 5 in there. What am I thinking? Ugh. Okay, let's start this problem over again. Let's say it's 3/4 log base 5 of the cubed root of 5. You know, I was going to put 5 and I'm like, stop using the same number. Choose a new number. And then, duh. That's why I needed it. Okay, so now I'm going to rewrite it using an exponent. So we get log base 5 of 5 to the 1/3. Now the cool part about this is we've got Tetris effect, right? And when you have Tetris effect, your answer is just the exponent. So we have 3/4 times 1/3. The 3's would cancel, and my answer would be 1/4.
How did the 1/3 and the 3/4 get to the times?
Well, because in Tetris effect right here, remember what happens? These cancel out and this drops down.
Oh, okay.
So now it's here. And this was times the log, so it's still going to be times the 1/3. And this is the part where I had a lot of people get to this part, and then they just didn't know what to do with that. So you're multiplying them because this is being multiplied. Any other questions about that one? Okay. And then,
We don't have to do that one. I just realized.
Descartes' rule of signs is not on the list. We can still cover it. Okay. So Descartes' rule of signs is, first off, it's just telling you how many positive and how many negative are possible. So for the positive, what we're going to do is we're just going to write down each term and whether it's positive or negative. So we got a positive, a negative, a positive, a negative, a negative, a positive, right? And now I'm counting out how many times it changes sign. So it changed sign there, and there, and there. It did not change there, but then it changed there, right? So if I count the loops, I've got 1, 2, 3, 4 loops. So that means for the positive zeros, it's going to be 4. You're going to have 4 of them, or you might have 2 of them, or you might have 0 of them. And the reason it goes down, do you remember why it goes down?
Because it does pairs.
If they're not positive, then they're complex. And complex always comes in pairs, right? If 3i is a 0, then so is negative 3i. So if it's not positive, then it's complex, and you got to take 2 away. And so that's a possibility. Now for the negative ones, that's going to be a little bit more interesting, a little bit more work. Because for the negative ones, I have to go, and for every time I see an x, I'm going to plug in a negative x. So when you do that, you're looking at this and you're saying, okay, negative x to the 6th power. The negative gets raised to the 6th power, so it's going to be positive, right? And it was already positive, so this right here is going to be positive. And then we have the next one. If I plug in a negative x, a negative to the 5th is negative, times a negative, that's going to be positive, right? Plug in a negative x here. A negative x to the 4th would give me still a positive. A positive times a positive is a positive. And then the next one, if I plug in a negative x squared will be positive times a negative. I'll get a negative. Oh, where am I? This one? Plug in a negative x times a positive. We get a negative. And then the 10 is still positive. I don't change that. Now when I count changes, I've got 1 there and I've got 1 there. So there's only 2 changes. So it's going to be 2 or 0 negatives. Okay, and so then this would be your answer for that. Now, what I don't understand is on the test, some people had everything right, but then down here they would write 3. Or they'd write 1. I don't know why. Like, this was all right, all the loopties were right, and then I don't know what they were counting because it wasn't the loopties. So, if you know, if you look at your test, if that's something you did wrong, you're going to want to figure out what you did wrong there. So that was the last of the questions you guys asked.
What's the remainder do?
The remainder theorem is a good talk about. So let's say I have f of x equals 5x to the third minus 4x squared minus 3x plus 10. And I want to find f of 2. Now we could take and find f of 2 by plugging a 2 here, 2 here, 2 here, right? But we also could use the synthetic division, where I put 2 in the box, and this is where I keep it the 2. I don't change the sign. I keep it the same. I write down my coefficients. I do synthetic division. Okay, and then I write down what f of 2 is. F of 2 is the remainder, 28. That's the remainder theorem. If I was to actually take and plug 2 in here and do all that math, I would get 28. Okay, now where do people go wrong? A lot of people will do this, and then they write down 5x squared plus 6x plus 9 plus 28 over x minus 2. That's not what we were looking for. I mean, yeah, that's one way to translate that, but that's not what we were looking for. I was looking for what is f of 2. And so you got to actually tell me f of 2 is 28. Okay? I don't want you just to leave me this bottom and be done. I need that translated into what does it mean.
So if you didn't have a remainder, just.
If you got a 0 here, you mean?
Yeah.
Then f of 2 equals 0. Uh-huh.
So, finding all the zeros from scratch.
Finding all the zeros from scratch.
Is that just
Like I gave you one of these and I said find all the zeros. So you do the possible zeros test to see what to try in here. And then you try them, and if you got 0 here, then it's a 0.
Okay. What about radical equations?
That is the square root equations. So radical equation, let's see here, these are pretty. Let's say we had the square root of x minus 10 minus 4 equals 0. So this is a radical equation. And the first thing you want to do is you want to get that square root by itself. So we're going to add 4 to both sides. So now I have the square root of x minus 10 equals 4. Then I want to get rid of the square root. So I'm going to square both sides. The squared cancel, you get x minus 10 equals 16. And then you just solve. At this point it's simple. X equals 26. Now, that was all simple and good. That's not probably what you're going to get. You're probably going to get one like this. X plus the square root of 31 minus 9x equals 5. So the first thing you do is you get the square root by itself. So we subtract x from both sides. So you have the square root of 31 minus 9x equals 5 minus x. And this is the tricky part, and this is the reason why you're not going to get a simple one, is because I want to make sure you understand when you square both sides, you square the whole side. See, the left side is already grouped together with the square root, so when you square it, you're squaring the whole thing. The right side, however, needs to be grouped together with the bubble, and you square that. So then the square root and squared cancel, you get 31 minus 9x equals, now 5 minus x squared means 5 minus x times 5 minus x. So you have to box that out. Okay, so you get 25 minus 10x plus x squared. And then your job is to get it equal to 0. So now we get 0 equals, I'm going to put it in order, x squared minus x minus 6. Then you box that out, see what you get. So let's see, 3 and 2, negative 3, positive 2. Set those equal to 0. So we get x equals 3 and x equals negative 2. And These are the types of problems that you have to check to make sure that they still work. Okay, and it's possible both of them work, but it's also possible neither of them work. I mean, or just one of them.
If you plug it in, you can't put a negative inside there.
Right, you don't want a negative inside the square root, because this, it would be fine if this had an I, but it doesn't. So you're not gonna want a negative in here. So, but you would just check, I would just check the whole thing at this point. So then you got 3 plus the square root, let's see. This would be 31 minus 27. Is that 4? So it'd be 3 plus 2, well that equals 5, so this one's good, right? Then I try the other one, negative 2 plus, if I plug in a negative 2, it'd be 31 plus 18. So that'd be the square root of 49. Am I right? Yeah. Yeah, so that's negative 2 plus 7, and negative 2 plus 7 is 5. That one worked also. So this one happened to work for both of them. A lot of times one cancels out or both cancel out. Okay. That's not the only kind of radian. If I keep looking at these, we've got this, it's a little bit simpler, and you guys did really well on your test on these. But what if you had that for your exponent? Then to get rid of that exponent, you'd raise both sides to the 2/3. So the 2's cancel, 3's cancel. On the left-hand side, you get x minus 5. On the right-hand side, now that you guys have found this confusing in the past, we have this 3 on the bottom. That means cubed root. So you're saying 8 to the 1/3 power. So the cube root of 8, which is 2. But you still have this top part, so it's still 2 squared. So you have x minus 5 equals 4. Add 5, x equals 9. And then you want to check that that works out in the bubble, which it does. Okay.